Okay, so for number one, for this game, I will go first and I will pick one starburst, and then that will leave 9 groups of 4 left. So each round, whatever number my partner picks, I will pick a number that will have the sum of 4, and then by the end, it's guaranteed that the partner will have the licorice. For number two, instead of this game, I still will go first, but I will pick 2 instead of 1. And then same as the first, going through, I will pick depending on what my partner picks to make sure that that number and the one that I have will have a sum of 4. So by the end, I'm guaranteed to have the $5 bill because her last round she'll only be able to have be able to pick 3. So even if she picks 2, I'm still guaranteed the 1 and then the $5 bill. For number 3, so for the first part, what I did was I have the 4 pizzas and I split 3 of them into thirds, and then the last one I split into ninths. So for them to have an equal size, equal portion of pizza, they could have 4/9 of that, just the 1/3 plus the 1/9. For the second idea that I had was I split the 3 pizzas into fourths, and then there was still remaining pizza in this one, so I split that into ninths, which had to carry over into the 4th pizza, which then had 12ths left. So with both pizzas, all of them will have 4/9 of the pizzas. So for number 4, the 52 times 41, with the doubling method, I doubled all of the numbers and then I chose the numbers 4, 16, and 32 because that equals 52. And then with those numbers that were by it from doubling 41, added those together to get 2,132. And for this one, it's basically the same thing, the same doubling method, except doubling the 52 instead. So for this, I chose the numbers 1, 8, and 32 because that's what equaled 41, and added the numbers from the doubling of the 52 together to get the same thing. So these technically are, they are similar and different. They're similar because they both will get the same answer, so the only difference is doubling these 2 numbers, and it will give you a different outcome to add together. But in the end, even with these different numbers, they still will come to the same. For number 5, 3,794 in Roman numerals is MMMDCCXCIV. So this is because the 3 M's is for the 3,000. Each M is equal to 1,000. And then the 700, the D is 500, and then the CC is 100, which equals the 700. And then for 90 and 4, it's different. So instead of writing out 9s a bunch of times, if you do the 10 and then 100, you subtract that. So it would be 90. So instead of writing out all those 10s, it just simplifies it. And then same for the 4. Instead of writing out 4 4s, 4 of the 1s, what you do is you do the 1 and then the 5, which means that the 1 before the 5 will equal 4 because you're subtracting 1 from the 5. And so for number 6, what I did was I got the areas of the hexagon and I added the different side lengths of the triangle to that. And throughout this equation, I just went through and simplified. So after simplifying everything, you do come to the conclusion that a squared plus b squared equals c squared. And same with the circles. The dashed line is the diameter of the circle that I did, which shows that it's the side length. So with the area of the circle, I added in the different side lengths and kept simplifying that until I came to the conclusion that a squared plus b squared equals c squared.